Thanks for tuning in to the Network Monitoring Crash Course series by Network Pipeline. My name is Zach, and I'll be introducing you to a few of the most important steps to ensure that your network is being monitored properly and securely. Without further ado, let's jump right in. In this video, we're going to review the fundamentals of SNMP and learn about what types of things we can do with it. If you're already familiar with SNMP and would like to get started with the instructions for deployment, feel free to skip to the next section in the video series, where I'll be showing you how to implement SNMP on a Windows machine step by step. So, what is SNMP anyway? Well, SNMP stands for Simple Network Management Protocol, and it's used to manage and obtain important details about the devices on our network. We can gather configuration and statistical information over the network using an SNMP monitoring or management utility. Some popular examples of these applications include SolarWinds, Nagios, Spiceworks, and What's Up Gold. With SNMP in place, we can tell our monitoring software to reach out to our device and ask questions or give commands, and then report back to us with the results. We can gain valuable insight into the statistics and health of our devices, allowing us to keep an eye on vital operational data and respond to problem areas that we may not otherwise have known about. We can get failure warnings and set up notifications when certain events occur on our network so we can respond right away. Further, we can gather metrics in real time to actively monitor a device, or we can store that data and refer to it later in the form of reports or graphs. And all of this is possible in a user-friendly graphical interface. Overall, SNMP is going to help us to keep tabs on our network and make our jobs easier by supplying the mission-critical information that we need to respond to and resolve issues that pop up on our network. We just need to make sure that when we do it securely. It's important to note that not all devices will be compatible with SNMP, but many are. Most business-level devices nowadays support SNMP, as well as many consumer-level devices like home routers and PCs. Devices that typically support SNMP include firewalls, load balancers, intrusion detection devices, routers and switches, wireless access points, servers and workstations, network printers, UPS devices, operating systems, and many different types of software applications. You'll need to check with each individual device to see if it supports SNMP polling. For a device to work with SNMP, it will need to have an SNMP agent installed. An agent is just a simple piece of software that sits on the device and is designed to respond to and act upon SNMP commands that are sent from an SNMP management or monitoring application. We'll need to make sure the agent residing on the target device is configured properly in order to receive and send SNMP data. Some devices have the agent pre-installed in the firmware or internal operating system, while other devices require that the agent be installed by you and configured. Again, you'll need to check with each device to see if the device you'd like to monitor has an agent that's ready to go, or will require installation of an agent prior to monitoring and management. By default, an SNMP agent is usually configured to respond to SNMP commands from any source, using the default security key or community string public, which is commonly known. This is kind of like how network devices often have the default login of admin and admin for the username and password. As you can imagine, this means that by default, SNMP is unsecure until you configure it to be secure. An unsecure SNMP deployment can be exploited by hackers, so it's important to lock down your devices as much as you can. In order to secure SNMP communications, you'll want to specify the IP address or host name of the server that's running the monitoring or management software that you'd like to use to pull this device. That way, only your monitoring machine will be able to send commands and retrieve information. Further, you'll want to change the default community string of public to something unique of your own choosing. Again, the community string is essentially the password for SNMP, so it's important not to leave the default community string on your devices if you'd like to keep them secure. There are actually 3 different versions of SNMP in this video series, but we're going to be focusing on SNMP version 1 because it's the most commonly used of the 3. We'll discuss the differences between the other 3 versions in a later video. There are 3 different community string types: read-only, read-write, and trap. The read-only community string allows a monitoring program to pull information from the device, but not make any changes. The default community string there, again, is public. There's also a read-write community string, which is used to pull data as well as issue commands and make changes to the device's configuration. The default community string for the read-write community is private. Finally, the trap community string is used to receive notifications from the SNMP agent on the device. We call these traps. We'll talk more about traps in a later video. Just keep in mind that the default community string for the trap system is the word trap. All of these pieces of information that we can look at are organized in a tree-like structure called the SMI, or the Structure of Management Information. It's basically a series of folders that we can drill down through in order to pinpoint different parameters and alerts that we want to monitor for. It's similar to the way a PC's directory structure is organized, where we're going to see different folders that we can click into to find more folders as well as files. Only here we're not looking at files, we're looking at specific statistics that we can watch or track. Each directory or parameter within the SMI has a unique identifier called an object identifier, or OID. An OID looks like a series of numbers separated by dots where each number specifies a location in the directory. An OID is almost like an address, where each consecutive number guides us on a path through the tree until we're able to locate the statistic that we're looking for. The OID just helps us find the parameter in the tree, but it doesn't tell us exactly what the parameter is. Just like how a street address of 123 Main Street tells us how to reach the building, it doesn't actually tell you what the building is or what's inside. We need something to pair that OID with a title and a description for the parameter in order to really understand what we're looking at. That's where MIBs come in. A management information-based file is required to translate the OIDs into human-readable form. We have to acquire these MIB files for each of our devices that support SNMP, since they're usually device-specific. Typically, you can go to the manufacturer's website to retrieve the MIB files for your device. They may also come loaded onto media that ships with the device from the vendor, so check the CDs that come with your gear. Once we've located the MIB files, we have to store them someplace. Depending on your monitoring software, you may need to load them into the system via command line or upload, or you may have to place them into a specific directory where the software is installed. We recommend creating a separate MIB repository for safekeeping. A MIB repository is just a suggested method of storing and organizing your MIB files. We usually create a folder called MIB repo somewhere safe that gets backed up, and in that directory we create folders for each of the manufacturers that we have MIBs for. Then inside those folders, create folders for each device and store the appropriate MIBs in there. Finding MIBs can be time-consuming and difficult, and they can become unorganized very quickly, so always keep them backed up in an organized folder. Once we've backed up our MIBs and transferred them into the monitoring software, we can then go ahead and set up monitors to check the responses of the OIDs that we select and alert us when something is wrong. In our next video, we're going to show you how to configure the SNMP agent on a Windows 10 device. Stay tuned for new videos with more helpful hints and instructions for network monitoring. Thanks for watching this video. Be sure to like this video and subscribe to our channel. Leave us some comments on what you liked and didn't like about this video. We'll use your suggestions to improve future videos. It really helps us out. See you next time with the Network Pipeline Network Monitoring Crash Course series. Thanks and have a great day.